Today we are going to begin the fifth module, and in fifth module you are going to explore chapter 10 from your textbook. We did chapter 1, 2, 3, 4. Now we are jumping to chapter 10, and in chapter 10 we'll be talking about correlation and regression. Okay, this is chapter 10. We are going to begin with some basic terms in this chapter. We are going to do the first half today, and we are going to begin with the scattered plot. So let's find out what is a scattered plot. When I say scattered plot, it's the graph between the independent variable and dependent variable. If you remember in first module, when you talk about the experiment, we talk about the independent variable and dependent variable. So if we draw the graph between the independent variable along the x-axis and dependent variable along the y-axis, and if we represent each point or each data with a point, then we get a graph which may be something like these two. Then that is called the scattered plot. So your scattered plot shows the direction of relationship between two variables. So here, when we are talking about a scattered plot, the goal is to explore the relationship between the independent variable and dependent variable. So whatever relation is there between the independent variable x and the dependent variable y. For example, if you look at this one, the first graph here, when you go from left to right, you can see that as the x value increases, the y values are also increasing. So when x value increases or when independent variable increases, the dependent variable, they are also increasing. And they are pretty much on a straight line. So we can say that there is a positive linear relationship on a straight line. That's a linear. Positive because when x increases, y is also increasing. So there is a positive and linear relationship. When you look at the second scattered plot here, when x value increases, you can see that the y values are decreasing. When you go from left to right along the x or the independent variable, the dependent variables are decreasing. So when one increases, the other decreases, meaning of that is there is a negative relationship. And all these points here, you can see they lie pretty much on a straight line. So there is a negative linear relationship between the independent variable or the x variable and the dependent variable or y variable. So that is the first thing. Always remember, it will give you the direction of the relationship. Second, a scatter plot demonstrates overall pattern and any deviation from the pattern. So when you look at the scatter plot, you'll be able to tell the direction and strength of the relationship. And sometimes you may also find that some points are a little bit far from the cluster of points, like this one. So that is the deviation. So if you see any point that lies quite far from the cluster of point, then we say that as an outlier. That is an outlier. So that is the basic definition of a scattered plot. Do you have any question on what is a scattered plot? Please unmute yourself.
No.
No.
Okay, great. So after we have the fundamental idea of a scattered plot, here is the example. And in this example, we are going to create the scattered plot by plotting these points on this grid. If you watch the lecture video on the module, what I have done is I did this problem on calculator. So make sure you watch that. That is one method of creating the scattered plot. You can create the scattered plot using TI-84 calculator. That is explained in the lecture video, which is posted under the module. Please watch there. Here, I'm going to create this manually. There are several methods, so I'm going to do manually. I'm going to plot the points here. So you can see what is given here. Absence and final grade. The number of absence, number of days you are absent from the class. Now, in our case, the Zoom meeting, and the final grade, whether it will impact the final grade or not. So we are going to create this scatter plot. The first point we have here is 6,82. When x equal to 6, y is equal to 82. So let's plot that. When X is 6, Y is 82. It is just above 80, that is 82. So it should be, hold on one second, 6 and 82. Look at that. Is that the point, 6 and 82? When it is 6 and it's above 82, that is the first point, 6 comma 82. Next, we have 2 and 86. When it is 2, it is 86. It's little above that. Okay, this line is 90, by the way, 80, 90, 100. So 2 and 86. So when it is 2, it is 86. Maybe that is the point. Okay, 2 and 86. Next is 15 and 43. So 14 is here, 15 should be this one. And then 83, 15 and 83 is that. 15 and 83.
43.
Oh, 43, 15 and 43. Give me a second. Let me clear that. Okay, 15 and 43. 40 is here, so a little bit above that. 15 and 43. Is that right? Look at that. That's correct, right? 15 and 43. Now 9 and 74. 9 is this one and 74. So this line in the middle is 70 and then 4. This is your 9. Look at that. And then this is 70, a little bit above that. So that is 9 and 74. 9 and then 74. Make sure you check the points, whether I'm doing it right or not. 9 and 74, then 12 and 58. 12 is here. So we have to go 58. So 40, that is 50 in the middle, 58. 12 and 58. Okay. And then you have 5 and 90. 5 absence. You're absent for the 5 times. 5 times, and you got a 90. 5 and then 90. Somebody's absent for 5 days and is still getting the final grade as an A. That is beautiful. I hope I could do that. And then the next one is absent for 8 days and the final score is 78. 8 days, 78, quite close to 80. Okay, that is a scattered plot. We are just asked to create the scattered plot. But what do you see? Look at the pattern. Now I want you to unmute yourself and answer my question. So what type of relation is there between the X variable and Y variable? That is the number of absence which are along the X-axis and the final grade. Do you think that the number of absence influence the final grade? That's my question.
Negative.
Please unmute yourself.
Negative.
There's a negative relationship, right? When the number of absence increases, then your final grade will go down, okay? So it's not a good idea to miss the class. That is the meaning. You can see there is a linear relationship between the number of absence and your final grade. That is the meaning. Do you have any question on this one?
Yes.
Yes, what is it?
Is number 9 and 74.
9 comma 74. Let's find it out if we plot it properly. This is 9, right? This is 60, 70, a bit above 70, 74. That's right.
So we put the wrong side.
We both are what?
It's a 9.5 maybe. It's not 9 exactly. Or I am wrong.
Here is 8. This is 9. That is 10. Mine look correct because this is 8. Look at this one. This is 8.
Oh, okay.
This is 10. So this is in the middle. That is a 9.
Okay, I got it.
Because I'm skipping by 1. Okay.
Okay.
Good. Okay, let's go to next example. So one more time, this example, which I just did here manually, this is done using calculator in lecture video. Make sure you watch that and learn how to use TI-84 calculator to create the scattered plot. Let me go to next example now. Same type of problem. We are creating the scatter plot again, okay? And what information is given here is, this is about the car rental companies. So number of car rented in thousands, like 63,000 car rented in a year, 29,000, 20.8 thousand, and so on. and how much revenue they make in billions of dollars, 7 billion, 3.9 billion, 2.1 billion, and so on. So that is the information given here. In the lecture video, I did this problem using Microsoft Excel. So make sure you watch that. So you have the other idea of creating the scatter plot, but here I'm going to create manually. So I have my x-axis and y-axis ready. So what I'm going to do is I'm going to start plotting these values. So if you look along the x-axis, you can see I have a 10 starting here. Then I have a 20, so I'm going by 5. So it's like 5, then 10, then 15, 20, and so on. That's how we have those numbers along the x-axis. And along the y-axis, I'm going by 1 billion, 2, 3, 4, and you can see there is 1 left in the middle. That means I'm counting by 0.5, 0.5, 1, 1.5, 2, 2.5, and so on. So let's plot. The first one is along the x, 7. No, along the x, 63. Along the y, 7, because this is your, let me use a different color now. This is your x value, this is your y. So 63, you can see 60 is here, so that will be 65. 63 will be here in the middle somewhere. And then 7 up, so you have to go and find that 7. 6 is there, so 7 should be all the way on the top, because we are skipping 1 and then counting. So your 7, if you want to label 7 here, so this is 7. So 63 and 7 should be this one. Okay, 63 comma 7. Next we have 29, which is close to 30, and 3.9. 30 is here, so 2.9 should be there. And then we have 3.9, which is close to 4. So close to 30, and then we go to close to 4. That is the point. 29 comma, so 29 is here, that is 3.9. Then we have 20.8, which is very close to 21. So you can say 20.8 is little bit above 20. And then we have to go to 2.1. From there, we have to go to 2 and little bit up 2.1. Like that, 2.1. Then we have 19.1. So you can see 20 is here. So 19.1 should be somewhere here, a little bit less than 20. And then we have to go 2.8, close to 3. Close to 3, 2.8. That is the point. 19.1 and 2.8. Next we have 13.4. So 13.4, you can see your 10 is here, this is 15, so 13 should be here, which is close to this middle line. Close to 15 is 13. So 13.4, and then I have to go 1.4, little bit above 1 and close to 0.5, so 0.4. So one more time, check here, 13.4. So little close to 15. Okay, and then 1.4. 1.4, that is the point. Then the last one, 8.5, close to 9. So this is 10, so 9 should be somewhere here. Close to 9, then we have 1.8, pretty close to 2. So that is the scattered plot. So a scatter plot is created. Here I created the scatter plot using the manual method. I manually plot the point and I created the scatter plot. But in the lecture video posted under the module, I created the scatter plot using Microsoft Excel. Make sure you watch that. Now you can unmute yourself and answer my question. What type of pattern do you see here? When the number of cars rented increases, what happened to the revenue? What is the relationship between the independent variable X and the dependent variable Y? Please
Positive.
unmute yourself.
Positive,
Positive.
positive linear relationship.
Very good. That is perfect. That is a positive linear relationship, because when the number of car rented out increases, the revenue they collect also increases. And you can see that when one increases, the other one is increasing. But you can see these points, they pretty much lie on a straight line. They are close about a straight line. So there is a positive linear relationship between the number of cars rented out and the amount of revenue collected in billions of dollars. Do you have any question on this?
Yeah.
Yes.
So it's only considered an outlier if it's like off to the side and not in the same line, right?
That's right. If it is far
Okay.
from the main line that you'll see here, then that is called an outlier. In the later example in the chapter, we are going to explore how we can check an outlier or how we can draw that line so that we can easily figure out the outlier. Okay,
Okay, thank you.
good. Any other question? Okay, look like there is no question, so we'll move forward. Okay, next concept. If you remember the name of our chapter, it was correlation and regression. So we are going to begin what is known as correlation. So when we say correlation, it will give you the strength of the relationship between the X value and Y value in the scattered plot. You have seen that in the scattered plot, you'll only get the direction of the linear relationship or direction of the relationship. You can say whether it is positive or negative. But this correlation, it will give you the strength of the relationship. How strong is the relationship? We are going to measure that using something called the correlation coefficient. So let's quickly read what is correlation. When we say a correlation, it's a relationship between two variables, definitely the independent variable and the dependent variable. The data can be represented by ordered pair. You have already seen in the previous two slides where we plot the ordered pair of the points, where X is the independent or explanatory variable and Y is the dependent and response variable. And when we calculate something called the correlation coefficient denoted by R, it will give you the strength and the direction of the relationship between two variables. And this is the formula to measure the strength of the relationship between the X and Y variable. So what I want you to do is quickly copy that formula on a sheet of paper because we are going to use that in next slide. Please copy the formula. You can see R is equal to N times, in the numerator, sum of X times Y minus sum of X multiplied to sum of Y, all divided by, in the denominator, there are two square root. In the first square root, N times sum of X squared minus sum of X squared. And in the second square root, you have N times sum of Y squared minus sum of Y quantity squared. That is the formula. And by using this formula, we'll be able to find the strength of the relationship. Our course wants us to know how to find the correlation coefficient directly on the calculator and also by using this formula. So we must know both methods here. Okay, I hope you have copied that. Let's go here. We are going to explore a little bit more about the correlation coefficient. After you calculate the value of R using this formula, the value of R you obtain that lies between -1 and +1, or the absolute value of R is between 0 and 1. So you must know how to interpret this. If your R is close to 1 or exactly -1, let's say, if your R is exactly -1, meaning of that is there is a perfect negative correlation between the dependent and independent variable. So perfect negative. If it is +1, then there is a perfect positive correlation between independent and dependent variable. If it is close to 0, then we say that there is no correlation between X and Y variable. Close to 0 or 0, there is no correlation between the variables. If it is close to +1, there is a strong positive correlation. If it is exactly 1, perfect. Close to 1, strong. If it is exactly -1, perfectly negative correlation. Close to -1, strong negative correlation. Not 0, but close to 0, weak. If it is close to 0, weak. So you can say here, if the value of R is, let me write that here. If the value of R is, I don't know why it is not writing. Okay, it's writing. If the value of R is close to 0, then we say that there is a weak correlation. If it is close to 0, there is a strong correlation. Strong. Here it is strong. Strong, but close to -1, so we say strong negative. Strong on the other side, close to +1, strong positive correlation. Over here, weak positive. Over here, weak negative. So that's how we can interpret the value of R. So we are going to take an example and we'll try to explain or interpret the value of R. Let's take that example. Here is that example. You also have this scatter plot, and we are looking at the scatter plot. Let's see what is asked here. For each of the following scatter plot, guess the correlation coefficient R. We are not exactly calculating here, so you are making a guess. Okay, you're making a guess, and then you are going to interpret the value of R. So everybody, you can unmute yourself and then try to answer my question here. So when you look at this first scatter plot, what type of relationship is there? When the X value increases, what happened to the Y value? So is there a positive correlation or negative correlation?
Positive.
Positive. So are these dots, do you think that they lie pretty close on a straight line?
Mm,
Doesn't look like.
Okay, so
not really.
not
Sort of.
really, not perfectly, right? So if it is not perfectly, it is not +1, but what can you guess about the R then? You cannot say +1 because it is not perfectly 1. So what could be the value of
Probably
R?
weak.
Say that again.
Is it near 0? Is it near
No,
0?
not exactly near 0. If it is near 0, then the point will be scattered far away from this line. They are pretty much on the line. Look at that. They are pretty much around the line, right? So we can say that R is pretty close to 1. So I can say 0.85. Okay. If it was weak, then these points will not be clustered like this. They will be pretty far from each other. Okay. So 0.85 positive. Let's look at the third one then. Look at the third one. What do you see? It's quite similar to that. When you go from left to right, is there a positive relationship or negative?
Positive.
Positive. And do you think that they lie perfectly on a straight line?
Yes.
Yeah.
Yes. So what is R equal to then?
1.
R equal to 1. Okay. R equal to 1. So in the first one, the points are not just like that. They are a little bit off, but a little bit around that. That's why I said 0.85. That is the meaning. Okay. What do you think about the second one? Is there a positive relationship or negative? The second figure here.
Negative.
Negative. And are these points exactly on a straight line?
No.
No, but they're close.
But they are close. Okay, so you can say this is negative. So what is your guess about the value of R then? They are pretty close. Okay, so they should be pretty close to -1. You can guess the value of R. It is not right or wrong. 0.9. I can take it.
Sure. 0.95.
Yeah, that
I don't
makes
know.
sense. 0.9. It will tell you that the points are, lying about a straight line. So this is how we can guess the value of R by looking at the figure. But in the exam, you'll not be asked to guess. Instead, the data will be given to you and you'll calculate. We're going to do that in next example. After we guess, see, we are asked to guess the correlation coefficient, and then we are asked to interpret the correlation coefficient. So we need to write the meaning of this. So what is the meaning of the first one? R equal to 0.85. What is that? There is strong, okay,
Strong
it's close to
positive.
+1. So yes, strong positive correlation between, make sure you write this, between independent between independent and dependent variables. Okay. How about the second one? How do you interpret that?
It's a strong negative correlation.
That's right. There is a strong negative correlation. Make sure you copy this in your notecatcher also. Strong negative correlation between independent and dependent variables. Independent and dependent variables. Great. How about the third? R equal to +1. What is the interpretation? You can unmute yourself. What do you think?
That's perfect correlation.
There is perfect
Strong
positive
positive.
correlation. Okay. There is perfect positive correlation. Positive correlation between independent, that is X variable, okay, independent and dependent. Okay, so this was pretty easy because we just look at it, we guess the value of R and we make the interpretation. In the next example, it will be a little bit different. What we are going to do is we are going to actually calculate and find the correlation coefficient. So here is that example. We are asked to calculate. See, we are not asked to find using calculator or anything. We are asked to calculate the correlation coefficient, okay? And we have to calculate this using formula. Clearly you can see we are calculating using formula. Then after we perform that calculation using a formula, we are asked to verify the result using calculator. So we are going to use the calculator and verify the result. So verify using calculator. And we are asked to interpret this in the context of the data. And you can see here, let's look at the data, what is given here. Here they have given the number of years the student is out of school. So like 1 year, 10 year, 5 year, 15 year, 3 year, 24 years, 30 years, and so on. And annual contribution, so this would be the dollar amount, that's also given. So when they are out of school for 1 year, they are contributing $12.5 to the college or the school. They're giving out that. After 10 years, they are just giving $8.7. After 30 years, they are just giving $2.70. So we are asked to find the relationship between the number of years the student is out of school, which is X, and the annual contribution Y. By looking at the time, I can see that we have little time left. So we are going to end this session. We'll take a 10 minutes break and we'll come back and start at 9:45. Is that good?
Yes.
Yes, sir.
So we have already seen the problem. We have the idea of what we are calculating here. We are calculating the correlation coefficient between the X variable, that is number of years the students are out of school, and their annual contribution. Now, what I want you to do is go to TI-84 calculator and then enter the data X value along the list 1 and then Y values along the list 2, because in order to find the value of R, you can see we need N. N means how many pair of data are there. You can easily count here, 1, 2, 3, 4, 5, 6, 7. So N should be 7. Then we are calculating 5 different sum. The first one is sum of X and Y. The other is sum of X, sum of Y, that is 3. Here is sum of X, here is sum of Y. Then we also need sum of X squared and sum of Y squared. We can pull all this information from TI-84 calculator. So we are going to enter the data and then we are going to pull all those information. So I'm going to stop sharing this screen and share TI-84 with you. Let me do that. So in order to enter the data, first you go to stat, then you'll go to number 1, which says edit, then enter. So in list 1, you enter the data, which is, let's enter together. The first is 1, and then you have 10. I have the calculator fixed to 4 decimal places. That's why you'll see those decimals. It may look different on your calculator. Then you have a 5, and then 15. Then you have 3. Then you have 24. Then you have 30. So you entered 7 pieces of information there. That's why it says I am in the 8th row. Now go to list 2 by pressing this arrow. Then in list 2, enter the data. 12.5 in the first. Then you have 8.7 in the second. Then you have 14.6 in the third. Then we have 5.2. Then we have 9.9, 9.9. Then you have 3.1. Then you have 2.7. Okay, are you also done entering the data? Just need your answer, yes or no?
Yes, sir.
Okay, now we are going to get those 5 things. So in order to get those 5 things, you press stat and then go to calculate. This time we are working on 2 variable stat because we have the independent variable and dependent variable. So we go to number 2, select number 2, and make sure you know that you enter the X values in list 1. So for the X value, there should be list 1. For the Y values, it must be list 2. We don't have any frequency. Then you hit calculate. Then you should get this information. So let's copy those information together. So look at that screen and tell me what is the value of n. N equal to how much? Look there. What is n equal to?
7.
7. Okay, n equal to 7. Then what is the sum of x? Sigma x equal to how much?
88.
Sum of x. What is there? Can you see
88.
my screen? 88.
Yeah.
Okay. Look at your screen, in fact. What is sum of x squared? Just below that, look at that. Sum of x squared is how much?
1836.
1836. Very good. And then if you go down here, what is sum of y?
56.7.
Sum of y is 56.7. Very good. There is an arrow there, meaning of that is there are some information below this. So for that, we click on this down arrow a few times, then we can see everything there. Okay, so we copied up to this one, sum of y. Just below that, there is sum of y squared. What is that equal to? Please read in your calculator. Sum of y squared is?
587.05.
587.05. You got the correct result in your calculator. Then there is one more sum down here, that is sum of x times y. What is sum of x times y in your calculator?
435.6.
435.6. See, we got all the information required from our calculator. Now I'm going to go back to the second screen by stop sharing this. Give me a second here. So the informations are copied here. What we are going to do is we are going to use this formula and find the value of R. So let's start plugging in the value of, or the values of different, sum that we have obtained here into this formula. So R equal to, make sure you plug in properly. See, this is your n. The value of n is 7. So 7 times, I can use that multiplication sign. I'm using that. 7 times the sum of x times y. Here we got that. Sum of x times y is 435.6. 435.6. Make sure you write it down because we'll be looking at this expression when we type this in our calculator to get the result. Then minus sum of x is 88 times sum of y is 56.7. 56.7. Then we have this divided sign, okay. Then we have this square root, the first square root. There are two square roots, so this is the first square root. Inside the first square root, we have n, which is 7, times sum of x squared. Look here, sum of x squared is 1836. 1836 minus, then we have sum of x squared. Sum of x, the value is squared. The sum of x is 88, so we have to square that. So 88 squared. So that's what we have in first square root over here. Now there is a second square root, and then you have n, which is 7, times sum of y squared. Here is that sum of y squared is 587.05. 587.05. Then minus, you have sum of y, and you have to square that. Sum of y is 56.7. 56.7, and we need to square that. 56.7 and square that. So that is what we have from the formula. Do you have any problem on how I substituted the values? I need your answer, yes or no?
No, sir.
Okay, so what we are going to do is we are going to type this together in our calculator, and then we are going to find the value of R. So I'm going to stop sharing this screen and share TI-84 calculator. Just a second here. Can you see my calculator?
Yes, sir.
Okay, so let's type what is there in the numerator. So to type everything which is there in the numerator, what we do is we begin a parenthesis. So first begin a parenthesis and type what was there. You can look at your notes. It was 7 multiplied to 4356, 4356, no, 435.6, right? 435.6.
Yes, 0.6.
Is that right?
Yes, sir. 0.6.
5.6. Okay, then minus 88 times 56.7. 56.7. Then close the parentheses so that this was all in the numerator. Okay. And then for the denominator, before we cannot draw because I'm typing like this, we cannot exactly draw that line here. So for that, we use the divide sign. Then to enclose everything in the denominator, we also begin a parenthesis. We are going to end that parenthesis at the end. So begin a parenthesis. Then there were two square roots. So first type the first square root. So in order to get that square root, you have to do second and then this sign, square sign. So you get a square root. And you have to type everything inside the square root, first square root first. So you had 7 multiplied 2, if you remember, 1836. Make sure you look at the note where you have written this, 1836. Then you have minus, okay, minus. Then you have 88 squared, 88. And here is that square. You press that and you get the square. Now, this is very important. Here you have to be very careful. See, you are inside the first square root. Now you have to get out of that square root. So in order to get out of the square root, press this arrow on your calculator. Now you are out of the square root and you are multiplying all this quantity with the second square root. So put a multiplication sign there. Times, now the second square root, second and this one. So you'll get the second square root. Now type everything inside the second square root. You had 7 multiplied to 587, 587.05. Then minus, you have 56.7 squared, 56.7, then square that. So you are still inside the second square root. So come out of the second square root. And after you come out of the square root, you are done with your denominator. So for that, you close the parenthesis and then hit enter. Now listen, if you have followed this step along with me, you'll get the same answer as I am getting here. Otherwise, you may have made some mistakes. So if you get something different, later on, you go back to the video, watch the video and follow it again, okay? Let's enter and check what we get. What did you get?
Negative 0.9078.
0.9078. You got it correct. That's what I got. Okay, negative 0.9078. I already verified this. That is the correct result. Negative 9078. Okay, I'm going to stop sharing this screen again.
Would be a strong negative, right?
That's right. So because your R is negative and very close to -1, there is a strong negative correlation between the number of years the students is out of school and their annual contribution. That is exactly the meaning. That is the interpretation. So let's write it down. Let me write here. You can also copy. There is strong negative relation between number of years the students are out of school and their annual contribution. And that is the interpretation, because we are asked to interpret in the context of the data. That's why we have to say there is a strong negative relationship between the number of years students are out of school and their annual contribution. Now, let's verify whether the value of R is negative 0.9078 or not using calculator. So I'm going to stop sharing this screen again and share the calculator. Okay, let's verify. So if you remember, what we did was we went to stat and then number 1, and we enter the data there. So that's our first step. After we enter the data, to get the value of R directly, please follow along with me. You go to stat, and then you go to calculate, which is this one here. Go to calculate, and then you press number 4, which says linear regression, number 4. And then check here, your X values must be in list 1, Y values must be in list 2. Then you don't have to do anything, just come down and hit that calculate. And here you should see the value of R. You don't have to look at other things, just look there. The value of R, we get negative 0.9078. Is that what we get from our calculation? Yes or no? Can you hear me?
Yes, I don't, my calculator's not showing R.
Yes, mine too.
Okay, that's a good question. So let's do one thing. If your calculator is not showing R, go to mode, everybody. If your calculator is not showing, go to mode, and then scroll all the way down and check this one, stat diagnostic. There should be somewhere, when you scroll down, you should see this, stat diagnostic. It cannot be off, it must be on. Turn it on, and after you turn that on, repeat the process again. Go to stat, and then go to calculate, go to number 4, and then calculate and see whether you'll get R or not.
Yes, sir. Thank you. That was it. I got it. Thank you.
Good, very good, very good. Okay. So what we did in this example is we calculate the value of R using formula. We verified using calculator, and we make the interpretation. So according to our course, we must know how to find the value of R like this by plugging in the values or using the formula. And also you must know how to check it quickly in your calculator. Both the goals are there in our course. So you must know both ways of calculation, and you must know how to interpret the value of R. Okay? Are you still there?
Yes.
Okay, good.